Good morning, my name is Sin Yee and I'm going to explain about question 1. So the software I'm using is Wolfram Alpha. Wolfram Alpha is a mathematical software which allows users to calculate and compute data. So we go to website and type what we want to calculate. In this case, it will be triple integral. So we type in all the value. And we run it. Then we get same answer as we calculate manually, which is 1.6917. So for question 2, we are going to use about double integral. So we type in double integral and we type in all the value that we want. And we will get the same answer as we calculate manually, which is 76/3. For question B, we are going to calculate about triple integral. So same as just now, we type in triple integral and we type in all the value that we want. And we will get the same answer as we calculate manually also, which is 6396.1. For question C1, we are going to calculate double integral again. So same as just now, we type in double integral and we type in all the value. And the answer we get same as we calculate manually, which is 15/8 pi unit. For question C2, we do same as just now, double integral, and then we type in all the value. And then we get the same answer, which is 0.4142.
Good day, Doctor. My name is Wong Ming, number matrix AE 2059. And today, I'll be representing my group, which is Group 1, to present about our question 2 for the multivariable calculus assignment. And the software that I'll be using is the MATLAB online software, which is the online version of the well-known software MATLAB. So first of all, for question 2, part A, part 1, we need to find the first partial derivative for the equation x squared times y divided by z cubed. And we need to find the first partial derivative fx, fy, and fz, which is the first partial derivative with respect to x, y, and z respectively. And we run the code, and we obtain the output for fx, fy, and fz, and we compare the value with our calculated answer, and we obtain that the answer are the same. Next, for question 2, part A, part 2, we need to find the first partial derivative of the equation exponential yz times cosine xy. And we have list out the variables available in the equation, which is x, y, z, and we need to find fx, fy, and fz, which is the first partial derivative with respect to x, y, and z respectively. And we run the code, we obtain the output fx, fy, and fz, and we compare to our handwritten calculation, and to conclude it is the same value as what we have calculated before. Next, for question 2, part B, we need to find the first partial derivative del z del u and del z del v, and we are given the equation x equals to u plus v, y equals to exponential v, and z equals to log x squared minus 2y. And we have listed down all the equations that are present in the questions, and differentiation z to u is the del z del u, and differentiation z to v is the del z del v. And we run the code, and we obtain the output for del z del u right here and del z del v right here, and we compare to our calculations, and it is the same as our handwritten calculation. Next, for question 2c, we need to show that the equation z equals to exponential y cosine x plus exponential x sine y will satisfy the Laplace equation, which is the addition of second partial derivative must be equal to 0. And we have key in our equation function z, and we have let a and b as the second partial derivative, which is del square z del x square and del square z del y square. And we have set out the final line of code to add a plus b together, and we need to prove that a plus b will be equal to 0. And run the code, and we will obtain that the second partial derivative, the addition, which is a plus b, is actually equal to 0, and it satisfies the Laplace equation. Next, for question 2, part D, part 1, we need to find the del z del x, which is the first partial derivative of the given equation. And from the given equation, I have shift all the values from the right hand side towards the left hand side so that it will be much more simpler to differentiate. And we need to find the fx and fz first before finding the first partial derivative del z del x, where del z del x will be equal to negative fx divided by fz. And we run the code. We obtain the value for fx, fz, and we obtain finally del z del x will be equal to the answer right here. And we can conclude that the answer for del z del x is the same as our handwritten calculation. And finally, for question 2, part D, part 2, we need to find the first partial derivative del z del x for the given equation. And as question 2D1, I have shifted all the values from the right hand side towards the left hand side, and the new equation will be in like this form. And we need to find the fx, fz before finding the del z del x, which is del z del x will be equal to negative fx divided by fz. So we run the code. We obtain the value for fx, fz, and the final answer for del z del x, which is the division of negative fx divided by fz. And we compare all the values up till now from question 2 part A until part D. We can conclude that all the answers we obtained through the MATLAB code is the same as our calculated handwritten value. And that's all I'll be sharing about. Thank you for your attention.
Assalamu alaikum. My name is Hamad Al-Jabri. My matrix number is AE20078. I'll explain about the third part of this assignment. Let me begin with the question 3a. The question is asking to calculate the divergence and CRL. So as you can see here, in the first 3 lines, we have put the seams X, seams Y, and seams Z. Then we have put the question as a MATLAB code with a divergence code. Then we can run it to get the answer. Here we can verify the answer C and D, and it's the same answer as our manual calculation. Then we can continue to the next question, which is question 3b. It's asking to find the work done by force field. Here we put it as a MATLAB code in the first line. When it moves from 0, 0 to negative pi 0 along the curve C1 and C2. Then in the next line, we put integral used to find the area under a curve. Alright, then the last line we have put F2 for the question. Then we can run it to verify our answer. Here we can get the answer for the question 3b, which is negative 31.0063, and it's the same answer as our manual calculation. Let's move to the last question, question 3c. As you can see here in the line 1 coding is defining the function to integrate, and the next line code it's for integration. Let me run it to check our answer. Here we can get the answer for question 3c, which is 1.821, and we have got the same answer in our manual calculation. So the question 3 is done and have been verified by MATLAB simulation. Thank you.
Hello, we are from Group 1 of Section 6, Multivariable Calculus, would like to present our assignment. Before we start, I, Fahim bin Azhan, my metric number is AE200121, and we are using the software which is called MATLAB to solve our calculation. For the first calculation, we recognize the variables first of x, y, and z, and then we differentiate it in x, y, and z. After that, we perform the divergence of vector field. Also, after that, we recognize the variables of r, theta, and z. Recognize also the f is equal to 1 plus r cos theta. and after that, the limits of the theta must be put in the calculations. So other than that, we also need to put the limits for r, z, and we also need to perform the z integral and the r integral. Also, do not forget the theta integral. So we convert the symbolic value s to the double precision. So we go to the next question, which is the 4C, the final question. We recognize the variables of x, y, and z, and then we differentiate it in x, y, and z, and also performing the curl of the vector field. So the curl of vector field is shown on the program, and n is unit vector oriented outward, and we perform the dot product as shown in the program. So we go to the equation of the triangle, and f is considered as the product of the dot product, and we recognize fun equal to 1 minus x. Also recognize y max equal to 1 minus x, and lastly we perform the double integration and we get the answers as shown.